What is meant by radiation? Radiation is the energy transferred by particles or waves. Radiations can be classified into two types. One is non-ionizing radiations. Examples are EM wave of low frequency. For examples, visible light, microwave are EM wave of low frequency, and this wave cannot ionize molecules. So we call these kinds of radiations non-ionizing radiations. Another kind of radiations is called ionizing radiation. Examples of ionizing radiations are: first, EM wave of high frequencies such as X-rays or gamma rays. Another examples of ionizing radiations is nuclear radiation,核輻射. Examples are alpha particles, beta particles, and gamma rays. Why ionizing radiations are so dangerous? Because ionizing radiations have sufficient energy to ionize the molecules, therefore they can damage the healthy living cells. What are nuclear radiations? Nuclear radiations are the emission of high energy radiations by the nuclei inside the radioactive source. Also, nuclear radiations is a spontaneous process. Spontaneous means this process of emission of radiations is uncontrollable. Let's see how radiations is discovered. The discovery of radiations, Banquist, he put a photographic film inside a box without light passing into it. And he put some uranium salt near the box. After some time, he found that the film was blackened. To explain why the film is blackened, he suggested the uranium salt emits some invisible radiations, and these radiations blackened the film. There are three kinds of nuclear radiations. The first one is alpha particles with symbol alpha. What are the nature of an alpha particles and its corresponding properties? First, an alpha particle is in fact equal to a helium nucleus with symbols. The atomic number is 2, which means that it gets 2 protons. The mass number is 4, which means that it has 2 protons plus 2 neutrons. Since an alpha particle is a helium nucleus, therefore the mass of alpha particles is equal to 2 times the mass of a proton plus 2 times the mass of a neutron. Also, since an alpha particle has 2 protons, therefore the charge of an alpha particle is positive 2 electronic charge. Since an alpha particle gets charged Therefore, it can be deflected by electric field and magnetic field. What are the speed of alpha particles? In fact, not all the alpha particles have the same speed. The speed of alpha particles has a range. The greatest speed may be up to 0.1 times the speed of light. The energy of alpha particles is mainly its kinetic energy, which is half mv squared. To memorize, the ionization power 離解能力 of alpha particle is very high. However, the penetration power 穿透力 of alpha particles is extremely low. Hence, alpha particles can be stopped by a piece of paper or a few cm of air. The second kind of nuclear radiations is beta particles with symbol. The nature of beta particles and its corresponding properties. First, beta particles are fast-moving electrons with symbols E, since a beta particle is a moving electron, therefore the symbol of beta particles can also be written in the form. For the mass number is 0, therefore a beta particle only has the mass of an electron. Next, how about the charge? Since a alpha particle is an electron, therefore it must carry the charge of an electron, which is negative electronic charge. Since an electron is charged, therefore beta particles can also be deflected by electric field and magnetic fields. For the speed, beta particles also got a range of speed. The greatest speed may be 0.9 the speed of light. The energy of beta particles is mostly the kinetic energy, half mv squared. Notice that the ionization power of beta particles is very low. However, the penetration power of beta particles is high. Therefore, it's more difficult to stop beta particles. A beta particles can be stopped by a few mm of aluminium sheet. The last kind of nuclear radiations is gamma waves with symbol. The nature and the properties of gamma waves are: first, gamma waves are in fact electromagnetic waves of very high frequency. Therefore, a gamma wave does not have atomic number, and the mass number also equal to 0. Simplified, we say a gamma. Hence, gamma wave, the mass is equal to 0, and the charge is 0, Therefore, gamma waves cannot be deflected by electric field and magnetic field. Since gamma waves are electromagnetic waves, therefore, all gamma waves travel at the speed of light, which is equal to 3 times 10 to the power 8 meters per second. And gamma waves carry energy, and its ionization power is extremely weak. Therefore, its penetrating power is very high, which means it's very difficult to stop all the gamma waves. If we use a few cm of lead plate, we can stop about 1/2 of gamma waves. What is ionization power? 離解力. When alpha and beta particles pass through air, since alpha and beta particles has charge, therefore they produce electric field, and the electric field produced by alpha and beta particles will exert sufficient large electric force on the electron inside the air molecules. As a result, the air molecules are ionized and produce positive and negative ions. And the kinetic energy of the alpha and beta particles are dissipated during ionization process to produce ions. When all the kinetic energy of these radiations is lost, the particles, alpha particles and beta particles, will be stopped. Hence, ionization is a process of energy transfer. The kinetic energy of alpha and beta particles is transferred to the ionization energies of the air molecules, which produce ions. Since the charge of alpha particles is greater than the charge of beta particles, therefore, the ionization power of alpha particles is larger than the ionization power of beta particles, which means that alpha particles will create more ion pairs than a beta particle for the same distance of travel. Since gamma waves is EM wave, which does not carry any charge. Therefore, the ionization power of gamma wave is negligible. How does the range in air relate to ionization power? Range in air is the distance traveled by a radiation before all its energies is used for ionization of air molecules. Or we say, range in air is a distance traveled by radiation before all its energies is lost. Because ionization power of alpha particles is stronger than the ionization power of beta particles, which is much stronger than the ionization power of gamma waves. Therefore, the range in air for alpha particles would be smaller than the range in air for beta particles, will be much smaller than the range in air for gamma waves. The range in air for alpha particles will be about 5 cm air. The range in air for beta particles will be about 1 meters of air. And the range in air for gamma waves may be over 100 meters. From the information of the range in air, we see that the penetrating power of alpha particles is smaller than the penetrating power of beta particles, which is smaller than the penetrating power of gamma waves. How to stop alpha, beta, and gamma radiations effectively? First of all, you should know that materials with greater density are easier to absorb radiations. Since the density of lead, aluminium, paper, and air are in the order therefore, alpha particles can be stopped by a few cm of air or a thin sheet of paper. Since the penetrating power of beta particles is greater than that of alpha particles, therefore, beta particles can be stopped by using a few millimeters of aluminium plate. Finally, the penetrating power of gamma waves is extremely high. Therefore, we can only use a few cm or above lead plate to stop gamma waves. How will alpha particles, beta particles, and gamma radiations be deflected by electric field and magnetic field? First of all, you should know that alpha particle is positive charge, beta particles is negatively charged, and gamma waves is EM wave which does not carry any charge. For two charged parallel metal plates, the electric field between the plate regions will be when alpha particles moving into the plate regions. Since alpha particles is positively charged, therefore it will be attracted by the negativity plate. Hence, alpha particles will be deflected downward. For beta particles, since beta particles are negatively charged, therefore beta particles will be attracted towards the positive plate. Hence, it will be deflected upward. Since gamma waves are EM wave without any charge, therefore, it will pass through the plate regions along the same straight line. That is, our gamma waves will not be deflected by electric field. Now, let's see a region of uniform magnetic field B perpendicular into the plane of the paper. Since alpha particles are positively charged, by Fleming's left-hand rules, when the alpha particles enter into the magnetic field regions, it will be deflect towards the left. However, since beta particles are negatively charged, by Fleming's left-hand rules, it will be deflected by the magnetic field towards the right. For gamma waves, since gamma waves does not carry any charge, it will pass through the magnetic field regions along the original directions without any deflection. Since the mass of beta particle is much smaller than the mass of alpha particles, therefore the deflection of beta particles in magnetic field and electric field will be much larger than that of alpha particles. Let's summarize these three types of radiations: alpha particles, beta particles, and gamma waves. Alpha particles is a helium nucleus. Beta particles is a fast-moving electron. Gamma wave is in fact EM wave of high frequency mass. Alpha particles has a mass of 2 mass of proton plus 2 mass of neutron. Beta particles has a mass of 1 electron. For gamma waves, it got no mass. Electric charge. Alpha particles had a charge of positive 2 electronic charge. Beta particles has a charge of 1 electron, negative E. Gamma waves does not carry any charge. The speed or energy. Alpha particles and beta particles have a range of speed. The alpha particle, the speed is as high up to about 0.1 speed of light. For beta particles, the speed is up to as high as 0.9 the times of speed of light. For gamma waves, it has a speed of light. For the ionization power, we have the ionization power of alpha particles is larger than that of beta particles, much larger than that of gamma waves. For the penetration power, alpha is smaller than beta, is smaller than gamma waves. Alpha particles can be effectively stopped by a few cm of air or a thin sheet of paper. Beta particles can be effectively stopped by using a few mm of aluminum sheet. Gamma waves can only be effectively absorbed by at least a few cm thick of lead plate. The symbol of lead is Pb. Both alpha particles and beta particles can be deflected by magnetic field and electric field because they carry charge. However, gamma waves cannot be deflected by E field and B field because it does not carry charge.